In this algebra tutorial, we will go over how we can solve exponential equations. We will do 10 examples ranging from basic to more difficult. Here's the first one. We have 2 to the 3x plus 1 equals 32. Now, here's the first thing you have to keep in mind. Whenever possible, we want to make both sides have the same base. On the left-hand side, we have 2, and we cannot break it down anymore. So we just have 2 to the 3x plus 1. But for 32, I think we can break it down, right? 32, it's the same as 16 times 2. And then we can keep going for the 16. This is the same as 8 times 2. And for the 8, it's the same as 4 times 2. And then for the 4, of course, is 2 times 2. So we have 1, 2, 3, 4, 5 2's. 32 is the same as 2 to the 5th power. Now, as we can see, they do have the same base now, and here's the property when we have exponential equations. Whenever the bases are equal, then the exponents must equal to each other. This is the one-to-one property for exponential functions. So we just have to make sure that 3x plus 1 is equal to 5. And now we can just solve this regularly. Subtract 1 on both sides. We get 3x equals 4. This is 3 times x, right? So let's go ahead and divide both sides by 3. And then we get x equals 4 over 3. Now, for the second one, we have 27 to the x power equals 9 to the 2x minus 3. Just like what we did earlier, let's take a look at the base right here. We have 27. And can we break down 27? Yes. 27 is the same as 9 times 3. And for the 9, we can write that as 3 times 3. So we have 1, 2, 3. 3 is multiplying. In another word, 27 is the same as 3 to the 3rd power. So we write 27 as 3 to the 3rd power and then raise that to the x power. Next, here we have 9. 9 is the same as what? 3 times 3 just from here, right? So let's just write the 9 as 3 squared and then raise that to the 2x minus 3 power. Almost, right? They almost have the same base. Now, check this out. We have 3 to the 3rd power and then to the x power. What we can do is just multiply the powers together. So multiply them, right? Multiply them. We get 3 right here for the base and then 3 times x for the power. Yeah, this is the multiplication by the rule of exponents. Now for the next one, this will be, here we have the 3 for the base and then we are going to multiply them. And this right here has 2 terms. So make sure you put parentheses. So we technically have to do 2 times 2x minus 3. Right? So again, this is 3 times x, and this is 2 times that. So now, again, same thing. They have the same base now. We can just go ahead and focus on the exponents. They must equal to each other. So we have 3x must be equal to 2 times 2x minus 3. For this right here, we can distribute the 2 real quick. And we have 3x equals, this is 4x. And then 2 times negative 3 is negative 6. Then, let's minus 4x on both sides. So that this and that cancel. And then we get 3x minus 4x is negative x equals negative 6. So finally, after divide both sides by negative 1, this becomes positive x. And that's exactly what we want, right? X equals negative 6 divided by negative 1. We get positive 6. Now, for number 3, we have 5 raised to the power of x squared plus 3x minus 4. All this right here for the power, and that's equal to 1. For the 5, cannot really break down. It's like 1 times 5, right? So this is just how it is. Nothing too much we can do. Let's just write it down. But now, how about for the 1? Can we really make the same base? The truth is, yes. For the 1, we can purposely write it as 5 to the 0's power, right? Remember, any non-zero number to the 0's power will give us 1. 5 to the 0th power is indeed equal to 1. So once you have that, again, they have the same base. So we can say this exponent must be equal to that exponent. So we're focusing on x squared plus 3x minus 4 equals 0. So now we have a quadratic equation. To do this, let's factor it. We just have x squared, so we know we must have x times x. And now think about two numbers that they multiply and get -4, and when we add them, we get +3. The correct combination will be plus 4 times -1. Plus 4 times -1 gives us -4. Plus 4 minus 1 gives us 3. That's equal to 0. So that means the first factor, x plus 4, should be 0, and the other one, x minus 1, should also be 0. From here, subtract 4 on both sides, and then we get x is equal to -4. And from here, just add 1 on both sides. So we get x equals 1. In this case, we do have two answers. Just like that. Okay, number 4. We have square root of 2 raised to the power of x plus 4. That's equal to 1/8. So let's try write both sides to have the same base. Here we have square root of 2. Don't work with radical, work with rational exponent. Radical 2 right here, it means the half power. So this right here, we can write it as 2 for the base, and then raised to the power of 1/2, right? And then we still have the x plus 4 power. Now, 8 is what? Well, if you break down 8 is the same as 4 times 2, and then that's the same as 2 times 2. So we have 1, 2, 3, 3 2's multiplying. So 1/8, right? 1/8 is the same as 1/2 to the third power. But this is on the bottom. Well, we will have to bring this up and make sure that we use negative exponent. So this is equal to 2 raised to the power of -3. This gives us 1/8. So for this right here, let's write down 2 to the -3 power. Now, again, we will multiply this power with this power. So we are looking at 2 raised to the 1/2 times x plus 4. Again, because it has two terms, so make sure we put parentheses around them. And then this is equal to 2 to the -3. Then we can, once again, because they have the same base now, put this power equal to that. So we get 1/2 of x plus 4 equals -3. Now check this out. We have 1/2 times this quantity is equal to -3. You can distribute the 1/2 and then do the usual business, that's fine. Or you can actually just multiply both sides by 2 to get rid of the 1/2. I think that's easier, so let's do that. I will multiply this by 2 and then multiply this by 2. 2 times 1/2, they cancel to be 1, and we just have x plus 4. And that will give us -3 times 2, that's -6. Then we'll just have to minus 4 on both sides, and we get x by itself, and that's equal to -6 minus 4, we have -10. Okay, for the next one, we have 5 to the x power, that's equal to 2. For the 5, you cannot really break it down anymore. Likewise for the 2, we cannot really break it down anymore. So they have different bases. Now what? The key is to use the logarithm. Here's the deal. Let me write it down right here for you guys. If today we see that we have some number b raised to the x power, and that is equal to a positive number, this is important because if you have a negative number right here, then the equation has no real solution. So if you have b to the x power is equal to a positive number, then this is what we are going to do. Here we still have b to the x power, and here we have that positive number, right? Just go ahead, take log, and then match the same base. This is base b. You do log base b on both sides. And make sure you write the log base b in the front. Like, this is how you enter it on the calculator as well. And then right here, you write down log base b of that positive number. When you do this, at the end, you will get that log base b and b to the x, the b right here, they cancel. You will just get the x by itself. And you just have to work that out. This is log base b of that positive number. And if you have to get like approximations, then in this case, on your calculator, you can just enter this as log base b of the positive number if your calculator has the base button. If not, then you can use the change of base formula. Let me just write this down right here real quick for you guys. Change of base formula, which says the following. If you want to enter log base b of that positive number, again, maybe your calculator does not have log base like 5 or log base 17. You will have a log, just a log, which is log base 10. What you want to do is write this as log, this is log base 10 of that positive number first, and then over, so you have to divide by another log, and then with that number b inside here. And notice this one right here, note, this log on your calculator means, even though we don't have any number here, but it means that we have log base 10. It's just that we don't write the 10 down. So right here, we have exactly this situation. We have 5 to the x power is equal to 2. In that case, we are going to take log base 5 on both sides, like this. This way, log base 5 and this 5 will cancel, and we'll just get the x by itself. And that will give us log base 5 of 2. And if you want to write the answer in the exact form, this is okay. Or if you want to get approximation, then in that case, you will have to get this to be log of this number inside first on the top, like this, and then divided by log of that base number 5 right here. And now if you enter this on your calculator, you will get approximately 0.4306 and so on, so on, so on. But if you round to the third decimal place, it will be 0.431. So this will be the answer, or approximated answer for that. Okay, number 6, we have 20e to the 3x minus 2, that's equal to 1200. What's the number e though? Well, did you notice it's over there, right? It's approximately 2.718. So it's just a constant. All right, this right here is our exponential part. We will have to get rid of. Okay, number 6, we have 20 times e to the power of 3x minus 2. Okay, number 6, we have 20 times e to the power of 3x minus 2. That's equal to 1200. What's the number e though? Okay, number 6, we have 20 e to the 3x minus 2. That's equal to 1200. But what's e? Well, did you notice it's over there already? It's a constant. It's about 2.718. But anyway though, this right here is our exponential part. We will have to isolate that first before we can do all this. So notice this is 20 times this part. We will have to get rid of the 20 first, and to do so, let's divide both sides by 20 so that this and that can cancel. And then we will just have e to the 3x minus 2, and that's equal to, we can reduce this, 1200 divided by 20, you get 60. Okay, and then after that, we have e to this power. Well, it's like this right now, right? So what we have to do is log with the same base. Here we have e. In fact, we are going to take the natural log. This one right here. What is it though? Well, I will have to write the note right here. ln means exactly log base e. So ln of this and that cancel. You can also write it as log base e, but use this because you have that button on your calculator if you want to get the approximation. So we are taking natural log on both sides. This is out. We will just have 3x minus 2 left. And then for this right here, I'm just going to leave it. We have ln of 60. And now I want to isolate the x. So I will just add a 2 on both sides first. So this and that cancel. And then we are going to get 3x equals, perhaps that's right here as 2 plus ln of 60. And then finally, just divide both sides by 3. And now divide the entire thing by 3. So that this and that cancel, and then I get x is equal to 2 plus ln of 60 all over 3. And of course, you can use your calculator, enter it on the calculator, and you can get the approximate answer as well. Okay, for number 7, notice we have 3 to the x minus 2, that's equal to 5 to the x plus 4. For this case, we cannot make the base the same. So we will have to utilize logarithm as well. For this one, I'm just going to go ahead and take log on both sides. You can do it this way, or you can check out my other video. I'll show you another way to do a similar question. Here's the property of logarithm. When we have log of whatever base, and then the inside is a number to a power, we can actually put the power to the front. This is one of the log properties. Likewise, right here, we are going to put the power to the front as well. And it will just be this times log of 3. So we are going to have that, but again, that has 2 terms. So let's write a parentheses, x minus 2. And then we multiply that by the number log of 3. So that's the first part. And then for the right hand side, you put the x plus 4 to the front. So x plus 4 in the parentheses times log of 5. And again, this right here is a multiplication. You don't need the dot. And this right here, log of 3 is just a number. This right here, same thing, it's just a number. So no more exponential parts, right? Well, let's just go ahead and do the usual business. This is a number. I'm going to distribute it backwards like this. I would like to write it as x times that. So we have x times log of 3. And then minus 2 times that. So it's just minus 2 times log of 3. For the right hand side, do the same thing. This times this times that. So this is equal to x times log of 5. And then we add 4 times log of 5. Like that. As you can see, we have the x on the left hand side here, and we have the x on the right hand side here. So like always, we want to put all the x's on one side and then the rest on the other side. I will move this to the other side by subtracting x, log of 5 on both sides. This and that will cancel, and now I'll do the same thing here. Minus x times log of 5. And then I will bring this number to the other side. I would just like to add 2 log of 3 on both sides so that this and that cancel. And I'll come here and do the same thing. Plus 2 log of 3, like this. Now have a look. Right here, I'm just going to write it as x log of 3 and then minus x log of 5. I know it's a long expression, but just calm down, just relax. It's like doing yoga, relaxing. Yeah? Okay. And then on the right hand side, we have this plus that. They have different logs, so we cannot combine, right? This is log of 5, this is log of 3, right? So cannot just do the 2 plus 4, no. Just write it down. 4 log of 5 plus 2 log of 3. What can we do next? Well, this has x, likewise that has x. We can factor that out. So I'm going to factor out the x. And then we will have log of 3 minus log of 5, like this. And then that will be equal to the right hand side. I'm not going to do anything with it, just leave it. 4 log of 5 plus 2 log of 3. Whew, we're almost done. Why? Because this is x times this quantity. All we have to do is divide it by that quantity on both sides, then we'll be done. So have a look. I will divide this by log of 3 minus log of 5, so that this and that cancel. And then, of course, go ahead and do the same thing here. We have log of 3 minus log of 5. And that's pretty much it. And usually when you have this kind of question for your pre-calculus or so, this will be the answer that you present, right? Or you can use a calculator to get the approximate answer as well. I'll write it down nicely for you guys though. X equals 4 log of 5 plus 2 log of 3 over log of 3 minus log of 5. So this right here is the answer. Is there a different way to do it? Yes, you can check out my other video for it. I think this is more of a standard way, so I would like to just show you guys this in this video. A side note though, if you took the natural log originally right here, this is okay as well. If you have 4 ln of 5 plus 2 ln of 3 over ln of 3 minus ln of 5, that's okay as well. Alright, I know number 7 was a little bit more difficult, so for number 8, let's practice a similar one. We have 7 to the 2x minus 1 equals 2 to the 4x plus 3. The base 7 and the base 2, we cannot make them the same. And then just imagine, why did we just take the log earlier? Because if you take log base 7, you cannot cancel that. You can cancel left hand side, but you cannot cancel the right hand side. So just take log, right, base 10. Go ahead and do that. Log, and if you want to do ln, that's okay too. Alright, now go ahead, put the power to the front, put the power to the front. So here we will have parentheses 2x minus 1 times log of 7, and that's equal to this in the front, so 4x plus 3 times log of 2. And then from here, this is just a number. I will distribute. So 2 times x times that. Usually we write down the number and then the variable in the log. So just go ahead and do it like that. 2x and then log of 7. And then minus 1 times that is just minus that. And then that's equal to, take this times this. Take this times that. So 4x times log of 2. And then this times that is plus 3 times log of 2. Alright, now you see we have the x right here and the x right here. So let's move this to the other side by subtracting 4x log of 2 so that this and that can cancel. And then do the same thing here. Minus 4x log of 2. In the meantime, let's get rid of this by adding log of 7 so that this and that will cancel, and then do the same thing right here, plus log of 7. Now on the left hand side, we have this minus that. Let me write it down. 2x log of 7 minus 4x log of 2. That's equal to, I know it's a lot of writing, I'm tired already, I know, but almost done. This is equal to, here we have 3 log of 2 plus log of 7. What do we do next? Here we see the x, here we see the x. Let's factor that out, right? Let's factor out this x, put it in the front, and then we have 2, and then log of 7, and then minus 4, and then this is log of 2. And then the right hand side stays, just leave it. This is 3 log of 2 plus log of 7. And then finally, you know it, we have x times this quantity, so let's just go ahead and divide it by 2 log 7 minus 4 log 2. Go ahead and do the same thing right here. 2 log of 7 minus 4 log of 2. So that this and that can cancel. And if you want to put this to the front so you can match the log of 7, up to you, but I'll just leave it like this. So finally, x equals that. So 3 log 2 plus log of 7 over 2 log of 7, and then minus 4 log of 2. Whew. Yeah, just like this. All right, number 9, we have e to the 2x plus e to the x minus 6 is equal to 0. Notice we have two exponential parts, e to the 2x and e to the x. And to solve this equation, we do the following. Look at e to the 2x as e to the x and then to the second power. Can we do this? Yes, because e to the x power and then to the second power, we just have to multiply the powers. X times 2 is 2x. So e to the 2x is the same as that. This is legitimate. And then we add e to the x and then minus 6, that's equal to 0. Now notice, we have e to the x here and also e to the x here. We can do a quick substitution. I'm going to say that y equal to e to the x. So that this equation becomes y to the second power plus y and then minus 6, that's equal to 0. Aha, we have a quadratic equation right here. So let's just go ahead and solve that. Because this is just y squared, so we can just go ahead and put down two parentheses like this, and then y and y. What times what give me negative 6, and together when we add them, we get positive 1. Well, the correct combination is plus 3 and then minus 2. And that's equal to 0. So this means y plus 3 equal to 0, or the other one is y minus 2 is equal to 0. So move the 3 to the other side, we are saying y is equal to negative 3. Move the 2 to the other side, we are saying y is equal to 2. Now, be careful with this. We are not done yet. We are not solving for y, we are solving for x. Y is the same as e to the x. So now we have to put this back here. The first equation is e to the x equals negative 3. But can we solve this? In fact, no. This right here has no real solution. There are complex solutions to this, but we are not going to cover that. No real solution. When you have an exponential function, you cannot get a negative number. Right? Remember what we did earlier? B to the x power has to be a positive power in order for you to apply the logarithm. And if you really want to just do the ln both sides, then you are going to get ln of negative 3 here. Right? If you do ln both sides, this right here, you will see the calculator will tell you it's imaginary, it's no real value. So you just don't do it. Right? Don't do it. So no solution for this, but let's take a look right here. We have e to the x, yeah, it's equal to 2. E to the x is a positive number. Well, for this one, we can take the natural log on both sides legitimately. This and that cancel. So for this part, x, it's equal to ln 2. And you don't need the parentheses, but I'll still put it anyway. Okay, last one. We have 2 to the x plus 3 times 2 to the negative x, that's equal to 4. Here we have a negative exponent, so let's fix that first. So this part becomes 1 over 2 to the x, right? That's what the negative exponent will do. And then let me just write down the rest. We have 2 to the x plus 3 times this, and that's equal to 4. So now we have an equation with fraction, so it's a good idea to multiply everybody by the denominator, which is just 2 to the x, right? So check this out. I will take 2 to the x times this term. So this is 2 to the x times 2 to the x. That's just 2 to the x squared, right? 2 to the x times 2 to the x. We have 2 of them, right? So I'm just going to write it down like this. And then next, when I take this, multiply with this term, the 2 to the x will cancel, so we'll just get a plus 3, right? And then this is equal to, lastly, we take 2 to the x times the 4. I'm just going to write it as 4, and then let me write down the 2 to the x in red like this. The reason why is because, you see that I did this on purpose, because this is similar to what we did earlier. I'm going to move this to the other side by subtracting 4 times 2 to the x, right? Minus 4 times 2 to the x. So that this and that can cancel. And then we get this right here is 2 to the x squared minus 4 times 2 to the x, and then plus 3, and that's equal to 0. Have a look. Isn't this like what we did earlier? Yes. So once again, we can just do a quick substitution, and I will just say, well, let's just do substitution. Let's let y equal to 2 to the x, so that we are getting y squared plus minus 4 times y plus 3, that's equal to 0. Again, quadratic equation. So now let's go and factor this. It's just y squared, so we need to have y and y. Okay, what times 4 give us positive 3, and together we add up and get negative 4. The correct combination is negative 1 and negative 3. So here, minus 1, minus 3, that's equal to 0. So that means y minus 1 should be 0, and the other one, y minus 3, should be 0. Move the 1 to the other side, y is equal to 1, and the other one is y is equal to 3. But y is what? 2 to the x. So 2 to the x, it's equal to 1, and the other number is 2 to the x, it's equal to 3. Notice both of them are positive, so we have answers. For this one, 2 to the x is equal to 1. What can we do? Well, we can actually write the 1 as what? 2 to the 0th power, and you see 2 to the x is equal to 2 to the 0th power. That implies x is equal to 0. So this is the first answer right here. I'm going to just write down x equals 0. But for 2 to the x is equal to 3. For the 3, we cannot do anything, right? So I will just take the logarithm on both sides. I will take log base 2, because I only have one base here. So log base 2, both sides. That way, this and that can cancel. And then we just get x by itself equals log base 2 of 3. Just like that. So 2 answers like this. And as a friendly reminder, if you want to enter this on your calculator, you enter this as log of what number? This number, the inside number on the top, right? And then divided by log, the base number is the number on the bottom. So this is how you solve an exponential equation. And if you have any more questions, you can leave a comment down below and let me know. That's it.